Hi, my name is Keely Lewis, and this is my lab report on constant velocity. So the purpose of this lab is to observe an object that is moving at a constant speed in the same direction, and to use the lab to help obtain a better understanding of Newton's fundamental principles. To use Tracker to analyze and obtain data of real-life examples of an object moving at a constant speed, and to create a computational model of an object moving at a constant speed in GlowScript to compare with the Tracker data. The fundamental principles that we're using in this lab are Newton's first law and Newton's second law. Newton's first law states that an object will stay at rest or in constant motion unless an external force is added upon it, and that is equal to F net is equal to 0. Newton's second law states that an object's acceleration is based on the object's mass and the force being applied, and that is equal to F net is equal to the object's mass times the object's acceleration. The formulas that we're going to use in this lab is a velocity formula, which equals to initial velocity plus F net divided by the object's mass times the change in time. And to the right, you can see where I applied this formula into my GlowScript code. The second formula is the position formula, which is equal to the initial position plus the velocity's average times the change in time. And to the left, you can see where I inputted this formula into the GlowScript. This is my video using Tracker where you can see that the golf ball is moving across the carpet, and you can assume that there is no external forces acting upon the ball like friction or air resistance. So some basic information that we're going to be going over in this experiment is the system and surroundings. The system in this experiment is the golf ball, and the surroundings is everything around the ball, which is mainly the carpet since it is moving on the carpet. For golf ball measurements, the mass is equal to 0.059 kilograms, and this will actually not affect the calculations because the mass ends up getting canceled out in the formulas. But the radius is 0.02135 meters. The initial position is written here, which I collected from using Tracker, and the initial velocity is also right below. And the equation that I use for the initial velocity equals the change in the position over the change in time. This is my code that I used in GlowScript. I did change a few things, which I changed the radius of the ball, and I also changed the mass, which, like I said before, later gets canceled out. I also inputted the initial velocity, or the initial position and the initial velocity, which I obtained from doing the math in previous slides. I also changed the interval of time because my data is collected in 0.05 seconds. And I also changed the time right here to the last point of data that my Tracker collected, which was 0.65 seconds. And then I've also inputted the formulas, which I talked about previously after I collected the data from the Tracker and from GlowScript. I then put it into Google Sheets and turned it into a chart, which you can see on the right-hand side. The red basically shows the predicted or the computation from the GlowScript, and the blue is observed from my data that I collected from my Tracker video. For the analysis, the observed object showed to be not constant. And at the beginning, it was more positive in position, but as time went on, it became more negative compared to what the model predicted. Some possible errors in the observed experiment could be the Tracker may not have been accurate, causing the data to be inaccurate, and there may have also been additional forces acting upon the system. Some what ifs. So what if there was the positive x and the negative x were interchanged? In my experiment, the ball rolled to the left in the negative x direction, resulting in negative slope. If the axis were flipped, the ball would now be rolling in a positive x direction, making the slope more positive. The individual data values won't change, except that their signs would be reversed, and the magnitude of the values, or the absolute distance or speed, would stay the same as below, since only direction is flipped. What does this mean? The observed experiment provides a general understanding of an object moving at a constant velocity, but it does not perfectly demonstrate it with complete accuracy. In real life, achieving a zero net force on a moving object is impossible because there are always unaccounted forces acting on it. No one can precisely calculate the exact number of pushes and pulls needed to achieve a total net force of zero. External factors such as friction and air resistance always play a role in influencing motion, also making it difficult to maintain a true constant velocity. This is my lab report, and thank you for listening.